Okay, after the introduction of the whole idea about this topic, and we have already narrowed down to pyramid, these are the few examples that purely dedicate to the idea of pyramid. So the formulas of pyramids will also be shown here. So for example one is a very simple thing. You realize that they didn't even want you to calculate the base area. Okay, we can see that the base is a triangle. So they already calculated the base area for you. And if you look at the height, it dropped down from the sharpest point. So we assume that this is the perpendicular height. So we get the volume by doing a 1/3, by doing a base area, by doing a perpendicular height. So this is not the issue. It's a very simple thing. Common mistake, people miss out on the 1/3. All of you are not used to using 1/3 because all your things are like half base times height. Trapezium is also half height times parallel sides. So you are not so used to 1/3. So you might write the 1/3 wrongly. So you might still be so used to writing half. So that will be the common mistake. In example 2, okay, it's a bit of the other way around. We don't have the heights. So the height, so see whether you want to denote it as a H, or you can use the algebra H, algebra X, and then it's a rectangular base. So I know that it's a rectangular base. They already told us it's a rectangular base. So if you want to be a bit more careful, you can explore the base area first by doing a length and breadth. So if you're not so confident, don't do all the working at one time, but label your working. So when you do 4 times 3, what are you looking for? You are investigating the base area. So then, okay, I'm given the volume. So maybe you would like to write out the formula and then we set it up like an equation. So it's 1/3 base area times height. So we're going to set it up as an equation. So the volume is 14. The base area we already calculated is a 12. So very much set it up like an algebra. So try to have the habit of setting up like an algebra. So this part will be a 4H, and you find your H. Okay, so that's also not a very difficult thing. Okay, so it's a bit like work backwards, but you could have like use a formula and then do it like an equation. So coming on to the next one is a bit longer, where they actually shows you the net and all the information. So your job is to find the total surface area. So this is a square base. So the square base will have 4 triangle, identical triangle. And the square is very easy. Square is just 5 times 5. The important thing, right, is to get the 4 triangle, and you got to recognize that the 4 triangle are the same. So in this case, I think it's quite easy. If I want to find the total surface area, it should be made up of a square and 4 identical triangle. I wouldn't advise you to do it in one chain. So I will advise you to do it one by one. So it's 5 times 5, that's 25. I will advise you to find one triangle, which is half times base times height. So I rather you find item per item before you find the total surface area. TSA stands for the total surface area, which is 1 square plus 4 sets of the triangle. So that is also not difficult, because they draw the net for you. You just have to see, and then you add up the pieces. So there are 4 triangles and a square for you to add up. So actually in this question, they could have continue to get you to find the volume. So if you will need to explore the volume, you will need the perpendicular height, which is currently not available. But do you remember, you can actually form a Pythagoras with the slant height. And this part is half of the width. So if let's say you really need the volume of this pyramid, you carry on your Pythagoras theorem to find your height. Okay, I assume you will know how to get to the h here. So do your Pythagoras, get the height. Then I can do my volume. Volume of this pyramid. 1/3. The base area is a square. And the height is the perpendicular height, which I found through Pythagoras theorem. So if I need to, this is how I'm going to find the volume. So the question could be extended for you to find the volume. Otherwise, the surface area is just like this. Okay, so this one will have a bit of Pythagoras in the pyramid. Okay, this is the one that's very similar to what we just went through, but it's a bit more difficult. So we got the square base. And we got the total surface area. So from the total surface area, again, what do you understand? It will be a square plus 4 triangles. So a square plus a 4 triangles actually add up to 2.8. So from here, what are we trying to know? So let's get the square first. The square will be 0.8 times 0.8. So from here, 0.64 plus 4 triangles will be equal to 2.8. So slowly, I'm going to work out the 4 triangles. So I want to work out one triangle. What is the area of one triangle? So I'm quite sure you know how to work this out. So where is the triangle that we are talking about? Here, this piece. This piece has an area of 0.54. And the base is 0.8. So it actually helps me to find the height here. So this will be 1/2 times 0.8 times Vn equal to 0.54. So I eventually arrive at the slant height. Do you realize? I arrive at the slant height. So this Vn is the slant height that I can form a Pythagoras theorem to find the vertical height. Okay, so if you couldn't see the Pythagoras, right, I'm going to draw for you here. So this is the vertical height of the triangle, and the slant height is the one that I just found. And this is 0.4. This will be half of this part. So can you see I can perform my Pythagoras to find my height, and then subsequently I can do my formula for the pyramids. 1/3 base area times the height. The base area is the square already. So you just need the perpendicular height. So can you try working it out to get the height and then to perform the formula to get the volume? It's very much like the example 3. So see if you can complete this last part on the volume and get the answer as 0.275.